Okay, now we've talked about concavity. Now we're ready to learn the second derivative test. In order to use the second derivative test, you must have a first derivative equal to 0. In other words, you must be at a critical point, or critical number. Normally, critical numbers, critical points, the first derivative is either 0 or undefined. The first derivative can't be undefined, though, because we need to get to a second derivative. Okay, so the first derivative has to be 0. If the first derivative is 0, then it's game on. So let's say that you're at a rock concert and you get all access passes to go backstage. And you're like, oh, this is amazing. And they're like, congratulations, first derivative. You have successfully become 0. You get a backstage pass. Come on back and meet the band. And so you go backstage where nobody ever gets to see where the second derivative lives. All right. If the c, that was a critical number that made the first derivative 0, gets plugged into the second derivative, and it comes out positive, congratulations, c, you made the second derivative positive, you're a minimum. Huh? Sounds backwards, doesn't it? But it's true. When I first heard that as a student, I thought my teacher had said it backwards, but no, he was right. Hey, C, congratulations. You're a critical number. You made the first derivative 0. Come with us. We're going backstage. We'll plug you into the second derivative. Congratulations, C. You made the second derivative negative. You're a maximum. Again, sounds backwards, but I think you'll see that this does make sense once I illustrate. Now, by the way, if you plug the C into the second derivative and it's not positive or negative, if it's 0, then the test fails. The second derivative test fails. You have to go back and use the first derivative test and make sign charts. Okay, let's see if we can make this make sense. Maybe it makes sense already. I don't know. But first of all, let's say that C is some random place on the x-axis. And it says that f prime of C is 0, meaning, okay, it's a critical point. It could be a max, it could be a min. I don't know what it is. Maybe it's a min. All right, maybe there's a min right there at C. Because the first derivative would have to be 0. Yeah, that's the slope. But if the second derivative is positive, you're concave up. The way that I drew this up here, concave up, so you'd have to be a min. I guess that kind of makes sense. And conversely, if the second derivative is less than 0, you're concave down like a frown. Remember, the first derivative was still 0, so you still have a 0 slope. You have to be a max. So even though it sounds backwards when I read it off, it makes sense. Now, if the second derivative is 0, the test fails. You have to go back and use the first derivative test. Okay. You could be a max or min still, but we don't really have evidence. You could be a point of inflection. You could be nothing. Let's try some examples to make the second derivative test feel more realistic. Number 6, find all relative extrema, all relative extreme values, maxes and mins. Use the second derivative test whenever possible. Here's what's up. A lot of you are not going to like the second derivative test. You don't have anything against the second derivative test. It's just that you're used to the first derivative test. You're comfortable with it. You like making the pictures and the sign charts, and you don't want to be taught a new trick. College Board and myself, we both can make diabolical problems where we force you to have to use the second derivative test by not quite giving you enough information to use the first derivative test. So as weird as that sounds, it is possible and it will happen. So you need to know how to work both tests. Although, if it's not in the directions, you can use either test. I'm going to show it using both anyway. All right, find the extreme values. Well, first of all, I need a first derivative. I'm just going to walk you through this pre-made problem. There's your first derivative. I already set it equal to 0. Because to use the second derivative test, we need to know, the critical points. So that can be factored. You can pull out a 2x. And your critical numbers, therefore, will be x equals 0 and x equals negative 6. So far, so good. All right, now we need to take a second derivative. So You take the 2x squared plus 12x, take another derivative, and the second derivative will be 4x plus 12, f double prime. Okay, so far so easy. Now we don't need to make a sign chart or anything. Here's what we need to do. We take the 0 and the 6. We're like, congratulations, 0 and 6, negative 6, I should say. You have pre-qualified to continue your journey. We're going to take you to the land of the second derivative. And in you go. 0, why don't you jump in first? And so 0 does. When you put the 0 in, it makes 12, which is a positive number. And I say, hey, congratulations, 0. You made the second derivative positive. You're a min. Again, it sounds a little backwards, but it's true. All right, negative 6, your turn. Jump in there. When you put the negative 6 in, you're going to get negative 24 plus 12. That'll come out negative. Congratulations, negative 6. You made the second derivative negative. You're a max. And now the directions said, find all relative extreme values. I have to point out that the 0 and the negative 6 are not extreme values. Don't circle that and be like, that's my answer. That's not right. The extreme values are the y-coordinates. So you have to plug the 0 and the negative 6 back into the original equation up here in black. I think you can see plugging in a 0 gives you negative 11, and it sure does. Plugging in a negative 6 is going to give you 61. And it makes sense that 61 is larger than negative 11, so it makes sense that the 61 would be the max and the negative 11 would be the min. So that's the second derivative test. Now again, some people are going to push back against this. They're like, I don't like that. I liked what we did before. I was comfortable. You're messing my comfort level up here. I'm like, all right, fine. We can go back and do the first derivative test. I told you to use the second derivative test. So if this is on a test, you're not following my instructions, I'll deduct. But let's just make sure that this we can verify this. All right, so we found the critical numbers, the 0 and the negative 6. Let's go back a little ways. If you try a number less than negative 6, let's say negative 7, and you plug it into the first derivative, which is right there, you can see you're going to get negative times negative, which is positive. If the first derivative is positive, you're rising. I think you can see that the negative 6 is fixing to be a max. If you try a number between negative 6 and 0, let's say you try negative 3, digital style here. That's going to be negative times positive, which is negative, you're going to fall. And if you try a number larger than 0, like 43, you can see it's positive times positive, which is positive, so it's going to rise. So you do get the same thing using the first derivative test. You get that 0, negative 11 is a relative min, and negative 6, 61 is a relative max. But again, the second derivative test allows you to not have to make the sign chart. And again, like I told you, like I'm warning you, we have ways of making a problem where only the second derivative test is doable and the first derivative test is not. So please, if I say use the second derivative test, if the textbook asks you to do that on your homework, you need to practice it. All right, let's practice some more. Speaking of practice. Practice, yes. Find all relative extrema. Use the second derivative test. Okay, first things first, first derivative. That looks pretty good. Let's set it equal to 0. Got to find our critical numbers. I'm going to factor out a negative 1, and I'm going to write the negative 1. If you don't write that negative 1, we saw this earlier, you might get all your maxes and mins backwards when you go to do your sign charts. Although we're not doing a sign chart because we're using the second derivative test, but you know what I mean. Okay, this factors further. So the critical numbers are x equals negative 6 and x equals 10. If these directions were not there, yeah, you can make a sign chart, you can do all that stuff. But those directions are there, so we have to move ahead with the second derivative. Okay, there's the second derivative. We go ahead and plug in the numbers one at a time. Let's try the negative 6 first. In it goes. you can see that that'll be positive 12 plus 4, that's 16, that's positive. So because the negative 6 makes the second derivative positive, it's a min. I have a feeling that 10 is going to be a max, but let's just make sure. Let's plug the 10 in as well. Putting the 10 in is going to be negative 20 plus 4. Yeah, that's negative. Congratulations, 10. You made the second derivative negative. You're a max. Of course, we're not done. We have to find the extreme values. So let me just get my answer set up right here. And just to save you a little time, let me go ahead and fill these in. There you have it. Hey, and for what it's worth, 474 2/3 is also the same thing as 1424 thirds. 1424 over 3. So that's number 7. Okay, more second derivative tests. We got a 6th power. This will be interesting. First derivative, right here. Second derivative, over here. Okay, first things first, we need to find critical numbers. So we'll take the first derivative, set it equal to 0. We can factor out a 2x to the third. That's going to leave me with x squared minus 4, which this is going to factor into x plus 2x minus 2. So we actually have critical numbers of 0 and plus or minus 2. All right, 0, you're first. Congratulations, by the way, of becoming a critical number. I know your parents must be proud. Let's send you in to the second derivative. Oh, no! The second derivative is 0. The test fails. All right, we're going to have to figure you out later. All right, bring your friends in, the 2 and negative 2, they can go in. Just to save a little bit of time, can you guys see that it doesn't matter if you plug a 2 or a negative 2 in, they're both going to do the same thing. So I'll just try the 2. 10. 2 to the 4th is 16. Okay, 24. 2 squared is 4. That's going to be 160. 24 times 4 happens to be 96. That's greater than 0. Congratulations, guys, gals, whoever you are, 2 and negative 2. You both made the second derivative positive. You're mins. I shouldn't say that you're mins. You're where the mins happen at. So 2 comma something is a relative min. Negative 2 comma something is a relative min. That makes me think that 0 is going to be a max, but who knows? So let me get my answer ready. I went ahead and took the liberty of plugging the 0 and the 2 and negative 2 back into the original equation, just because I knew they were all critical points. So I figured, let's get the y coordinates. So a pair of twin mins, even though I'm calling these two relative mins, technically they're both absolute mins. Saying relative min is okay because the directions just said, hey, find the relative extrema. It didn't say tell which ones are absolutes and which ones are relatives. So that would have been an issue if it said that. I'd have to be more careful. All right, what the heck is 0, 0? It failed the second derivative test, so I will have to go back and make a sign chart for it. So here's 0. And I feel obligated to maybe put the negative 2 and 2 on just for the heck of it, even though this is not necessary. I really only am testing the 0. Let's use red because I'm going to go back to the first derivative, which is right here. Again, I don't need this equals 0. If you try something to the left of 0, let's say I try negative 1 right here. You put a negative 1 in. This out here is negative. Negative 1 squared, that's 1 minus 4, that's also negative. Negative times negative is positive. First derivative, positive means the function's increasing. I had a feeling 0 is going to be a max, I think it will be. Let's try positive 1. If you try positive 1 in, this out front becomes positive. This is still negative because it's still 1 minus 4. Positive times negative is negative. Yes, the first derivative test showed that yes, indeed, 0, 0 is a relative maximum. And by the way, 0, 0 is not an absolute max, because this graph is eventually going to fly way up. When you start plugging in real large numbers, that sixth power is going to make it go crazy. So there you go. And I went ahead and gave you guys a multiple choice question just to see if you would get it right based on what you've learned. So give it a shot. We want to know, what are the x-coordinates of the points of inflection? Well, since this is already the second derivative, let's just go ahead and we'll try each region and see if the concavity is in fact changing. First of all, I don't need to think about this x minus 8 squared or this x squared, because anything that you would plug in would make those positive. So the first parentheses is going to be positive, and so will the last parentheses. So those aren't even in the picture, which likely means that 0 and 8 probably aren't going to be points of inflection. So let's go ahead and try each region. Let's pick something less than -3. We'll go for -4. -4, being plugged in, would turn this negative and this negative, which is positive, so that's concave up. Let's try a -1. -1 would still make this third parentheses negative, but a -1 here would turn that positive. So that's going to be concave down. So yes, -3 is a point of inflection, which means A and D are out, so is E. So it's down to either B, C, or F. Let's forge ahead. Let's try something between 0 and 5. I think we'll go with +1 on this. If you plug in the +1, that's 4 to the third, that's still positive. 1 minus 5 is still negative. That's still going to be concave down, so 0 is not a point of inflection. I kind of had a feeling it wouldn't be, so F is the wrong answer. I have a feeling F is an answer a lot of people chose because they just blindly looked at this and saw the 4 numbers and thought, it's going to be it. But it's not, so we basically just have to finish up between 5 and 8. We don't have to go past 8 because none of the other choices have 8s in them, so I don't really care what happens over there. Let's pick a number between 5 and 8. We'll go with 7. +7 in there. That's making everything positive. And of course, anything bigger than 8 would do the same. So this is concave up. Just for the record, so is this. There's another point of inflection at 5. So the correct answer is choice C, -3 and 5 only. Let's try another one while we're at it. It says the function f of x has the property that f of x, f prime of x, and f double prime are all positive, like all the time. Which of the following could be the graph of f? All right, let's break this down. If f of x is positive all the time, you cannot go below the x-axis. It looks like all 5 of them are okay. I don't know what's going to happen with E if it eventually is going to go below, but you really can't assume that. So all of them are still alive at the moment. But if the first derivative is positive all the time, that means that the graph is always increasing. It's constantly rising. So A is out because A starts falling. C is falling all the time, so it's out. B and D are alive, and so is E, assuming that it doesn't cross. And finally, the second derivative also being positive means concave up. B is concave up, that's part of a smile. D has a point of inflection in it, so the concavity is changing, that's out. And E is concave down, so it's out. So B has to be the correct answer to this one. So there you go.